So if you weren't here when I ran the pre-class introduction, this is what we're going to be getting into today. To talk about circles, which is a pretty familiar idea, and I'm going to show you why, we first really need to just learn how to talk about it. So we got to learn these technical little details like radius, diameter, circumference, and area. We'll talk about those things, but I'm going to make sure that they make as much illustrative sense as possible. I'm going to use imagery. I'm going to make sure that it makes sense on paper, in your eyes, in your brain, before we actually get started tackling problems. So get ready for a lot of little pop quizzes. It's going to be a lot of fun. Now, number two, once we actually know what we're talking about, then we're going to learn how to identify what we're talking about. Because remember, guys, when it comes to word problems, like, are they always going to give you the exact math terminology in the word problem? Or is that something that you sometimes got to figure out for yourself? I'm going to zoom down here. Right, exactly. You have to figure it out. Like a lot of the times you have to read the word problem. You got to decipher those clues and you got to figure it out. So first, we need to make sure we know what we're talking about. And once we know what we're talking about, then I'm going to teach you how to spot it in the word problems, how to identify those keywords and phrases. So we can basically turn that English into math. That's really what the goal is. So let me go ahead and let this person in here. And let's keep moving forward. So let's get into main notes right away. Let's have some fun. So main notes right here for circles. Everybody just go ahead and draw that diagram. It's a very simple one, even though nobody here can freehand draw a circle, including me. But go ahead and draw that circle. And I'm going to go ahead and talk about some of these definitions. Don't worry about this up here. We're going to zoom in right here. So I'm going to give you just about 15, 20 seconds, and then we'll have a conversation about all this and what this means. And once you're ready, go ahead and type right in the chat box. Perfect. Hey, no worries, Damien. I mean, at least we finally found something you're bad at. Hey, Debbie, I got that message. Go ahead and shoot me that text directly. I got you. Hey, Caleb, we'll flip that attitude. So let's go ahead and talk about this here. My party people, pretty much a circle. I don't think I need to tell you what a circle is, right? It's a pretty round object. It's round all the way around. And depending on how much math you've taken in your life, you might think it's a bunch of sides infinitely or no sides at all. We're not going to get into that. I'm just pretty much venting about the PTSD I had in college for these math classes. So let's go ahead and simplify this and make sure that you're not doing anything crazy. This is all you got to know. Number one, circle, radius. A radius is pretty much how far it is from the middle of the circle to the edge. That's it. That's it. That's all the radius is, my party people. Don't worry about diameter. Just worry about radius. Radius is pretty much saying, hey, how far is it from, one moment, everybody. There we go. Oh, wow. It looks like it was mischarging the whole time. No worries. So with that, no worries. I'm going to start off here. The radius. Remember that the radius is simply going to be the distance from the middle of the circle to the edge. All right, the middle of the circle to the edge. Now, you might already be looking at diameter, and the diameter looks like you're going from one end of the circle all the way to the other. Okay. Everybody, is there anything you know already coming into this class or something that you might want to guess about the relationship between the radius and diameter? Is there anything that you might notice? And let's go ahead and keep the conversation in the chat box relevant to what we're doing. So what's something that we might see or make a relationship about here? Okay, I see a lot of you saying that the radius is half of the diameter is double the radius. Both are absolutely correct, absolutely correct. Now, there's one more thing that I really want to point out that will help us prove the point. Everybody, where do the radius and diameter meet up? Where do they touch? In the center, yes. So with that said, let me go and just connect this new pencil here. One moment. Cool. All right. So with that said, my party people, they both pass through the center. And because they both pass through the center, let me show you why the radius is actually half of the diameter. Let me show you why this actually makes sense. So if we take a look here, there's the center. Everyone, quick question. Is the radius only supposed to be going to here, or can it be here, here, here? Can it be anywhere as long as we touch the edge, right? Can it be anywhere as long as we touch the edge? That's right. Okay, cool. So let me go ahead and do this. Boom, right there. That's one. So everybody, is it true that this would be considered a radius right here? That would be considered a radius? Okay. Now, what if we went the other way? What if we said, okay, cool. So the same idea applies, but what if we just went directly to the other side? Everybody, is that also a radius? That red arrow, is that also a radius? Absolutely. Now, what do we notice about this? Let's just talk about what we notice. If we connect the green and the red here, is that not the diameter as described to us? Right? The diameter is going across the circle through the middle. Go across the circle through the middle. We put two radii, radius times 2. We put these radii together, and we see that. We see that, boom, right there, the diameter is 2 times the radius. And so I'm really hoping that intuitively, at the very least, this can make sense. So if you're looking to write down these definitions, here's what I'm going to challenge you to do. I want you to find a way to write this in the way that you understand it, with your words. So I'm going to give you 2 definitions. Number 1, radius. The radius is basically the distance from the center to the edge of a circle. That's my way of saying it. You can say it your own way. But again, the radius is the distance from the center to any edge. The diameter, you can define it as, and a lot of people like to go with diameter is double the radius. The more formal way of saying it is going to be the diameter is the distance across a circle through its center. That's it. So I'm going to go ahead and write those down now, but I want you to, again, when you start taking notes from now moving forward, do your best to write it in the way that makes sense to you. That way, when you look back on your notes, it's not like you're reading it as if I was just saying it, but it's like you're saying it to yourself. So let's write this down here. Let me go ahead and take these notes down right here. So radius, the distance from the center to the edge of the circle. And then number 2, the diameter. And I'm going to give you, again, both definitions here. I'm going to give you both definitions. So number 1, double the radius. And then the other definition is going to be, again, the distance across a circle through the center. You got to make sure you say that, because if not, it's actually called what we label as a chord, which you don't really need to know. Don't worry about it. But the definition changes. The term changes if it's not going through the center. Just make sure that you are saying it's going through the center, and you notice that when you're doing a problem to call it the diameter. So the distance across a circle. Now I'm being very, 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 how do you say? I'm being a little devious right now. I'm pointing something out excessively, and that's the distance across the circle. Because everybody, remember my conversation, that little point I made earlier. Word problems are not always going to give you the exact term lined up. They're not going to say the diameter of a circular pond is 10 meters. They're not going to say that. Well, they can, but they could also say the distance across, or the distance directly across a circular pond is 10 meters. Now, everybody, is it true that in both cases, the one where I said the diameter of a circular pond is 10 meters, and the other scenario where I said the distance across a circular pond is 10 meters, is it true or is it false that in both scenarios, I was talking about the diameter. Now you're starting to get it. So if you weren't, if you didn't have that confidence before of understanding what I mean by that, hopefully now it makes sense. Again, they're not always going to give you the terms, but knowing the definitions, taking the time to actually go through and talk about the terms, this is going to spell success for you. So don't shy away from doing this in any concept. Even though it's boring at first, make sure to do it. So the distance across a circle through the center. Okay, so there is that. I'll give you a few more moments to go ahead and write that down. And then next up, what we're going to do is we're going to start talking about some of these more technical terms, like the calculations, such as, hey, what's the circumference and what's the area? There are formulas for them, but we want to know what they mean first before I actually give you the formula. So Remy, if you're given the radius and they tell you to find the diameter, absolutely. Absolutely. If they give you the radius and tell you to find the diameter, the way that you get to the diameter is you double the radius. Yeah. If that's what you have. So with that, essentially, JB, essentially. Cool. So there it is, my party people. Now let's go ahead and start talking about circumference and area. Now, I want to see who knows this already. Can anybody tell me, when it comes to circumference, is there another math word that it relates to? What's the closest related math word to the word circumference? Who knows? And we'll talk about that, Remy. No worries. What's the closest related math word to the circumference of a circle? Let's see who's got that. And so far, I don't think I've seen many people, maybe like one or two. So let's talk about this. First of all, let's write out the definition formally, and let's see if you get it once I give you the definition. So right here, circumference. And remember, even if you're confused, make sure to take the notes down as you understand them, because we're going to have a little pop quiz in a moment to really help you understand the relationship between radius and diameter. So we'll come back to that in a moment. I didn't want to do it right after. I want to give you everything, and then we'll focus on each one individually. So circumference, let's see who recognizes this. Does anybody see the relationship now? Does anybody see the relationship now? Ah, there it is. Yep, perimeter. There we go. There we go. Yes. The distance around the circle is the definition of circumference, but that's so closely related to the idea of perimeter. They're actually the same exact idea. The only reason that we don't call circumference perimeter is that a circle doesn't apply to the rules of perimeter. Everybody, the rules for perimeter, or the definition or formula, isn't it add up all the sides? Isn't that what perimeter tells you to do for any regular shape? Perimeter basically says add up all the sides. Okay, great. Quick question. When we look at a circle, it doesn't really have any sides, right? It's pretty round. It's not actual edge. There aren't edges here. It's really, really round. So because it doesn't fit within that property, that definition, they just came up with a different term for it, and that's called circumference. So if you're curious, or not curious, but if you just want to make things simple, circumference is the perimeter of a circle. That's it. It's the perimeter of a circle. If you want to make it simple, the circumference is pretty much just the perimeter, but of a circle. And there's a formula for it, and we're going to write this down right here. The circumference of a circle, go ahead and write this down right here. And there's two formulas. Let me actually write down the second one for you. Right there. Circumference equals that little symbol right there. That's called pi. And let me go ahead and fix that. 2 times pi times the radius. So there are two formulas for circumference, But I want you to notice something there. One just says pi times diameter, and the other one says 2 times pi times radius. Hold that thought. We'll come back to that in a bit. Don't worry. We'll come back to that in a bit. And then one last thing, we're going to talk about the area. So the area is right here. And the area will give you all of the space within that shape. So the idea is the same. Again, the formula just changes here. And the formula is going to be specifically pi times the radius squared. So go ahead and write that down too. And again, it's all good if we're not totally here and saying, hey, oh yeah, great coach, that makes total sense. It's all good if we're not quite there, because again, we have to learn the definitions, apply them in practice to see how we can truly build these connections. So stay patient, we got this. But we're gonna have a little moment here for a little pop quiz, and we're gonna have some fun. So really quick, everybody, let's go ahead and show you everything. That way you can continue writing anything down that you're missing. But let's have a little moment where we just openly discuss this. In the chat box, hit me. What's the radius? In your words, what's the definition of radius? If you want to go ahead and just look at what I have on the screen, sure. But my goal is to see if you can talk about it in your own way. Can you talk about it in your own way? How do you see the radius? What's the first thing that comes to mind? Yeah, JB, it would. And I'm going to do that. I was actually doing that in a moment after the pop quiz, though. I got you. Okay, cool. So I see a lot of us saying half of the circle. Then I see a few more of us saying middle to the end of the circle, the distance from the middle to the edge, the center to the edge, half of the circle. So be careful. Half of a circle, that's a semisphere. So let's be careful about that. Let's go ahead. Not half of the circle. You could say half the distance across a circle. That's an acceptable way, but I wouldn't say half of a circle because it sounds like you're cutting a circle in half. The distance from the center to the edge. Right, the reach from the center to the edge. There we go, I like these. There we go. Good. Okay, now let's see how you can answer this in your own words. How would you relate the diameter to the radius? How would you come about that? How would you relate the diameter to the radius? So I like how Zoom hears you. You said straight line measurement from the center of a circle. That's cool, but how does that relate to the radius? Can you give me a statement where you relate diameter to radius? Multiplying the radius by 2 times radius. Okay. Both aren't quite lines, but that's close. They aren't quite lines. One's a ray and one's a line, but yeah. Or they're both segments, essentially. But okay, so I see a lot of us, when it comes to the relationship between radius and diameter, you're good with that. You see that if you have the radius, double it to get the diameter. So now here comes the part of the pop quiz where I'm going to have you actually calculate and actually think about this. So everyone, the radius is 10. What's the diameter? Go, chat box. The radius is 10. What's the diameter? 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 And so this is the point that I want to prove. So remember, everybody, it's not about memorizing things. It's about truly understanding things. So I'm not going to give you the correct answer yet. All I'm going to do is say this. Everyone, which one is bigger, the diameter or the radius? Which one is bigger always? Right, the diameter is always bigger because it goes all the way across the circle, but the radius only goes about halfway. Exactly halfway, to be honest. So, everyone, I started by saying the radius is 10. In your opinion, is the radius smaller or bigger than the diameter? One more time. Is the radius smaller or bigger than the diameter? Yeah, the radius is going to be the smaller one. So, does anybody want to change their answer for me? When I said the radius is 10, what should the diameter be? Does anybody here want to change their answer? And there we go. So notice how I did not sit here like most traditional teachers and go, no, diameter equals 2 times radius. 2 times 10, 20. That's not the way that learning should be done, in my opinion. There's a million ways to teach and learn, but in my opinion, I think the best way is to discover the answer, the reason why it's correct for yourself. Did that make sense for you guys? Did it make sense that we were supposed to double that 10 to get to the diameter? Sounds good. And I know I do take my time in the beginning of classes, but we know we are going to ramp it up right about the halfway point. So, next question. The diameter is 50. What's the radius? Go. The diameter is 50. What's the radius? The diameter is 50. What's the radius? The diameter is 50. What's the radius? All right, let's talk about it. So everyone, if we have the diameter and we're trying to go to the radius, let's think about that. Are we going to the smaller or the bigger? Like, we're starting from the diameter. Are we going to a smaller or a bigger idea here? Yeah, we're going to a smaller idea. And exactly how much smaller is the radius from the diameter? Exactly how much smaller? Yeah, half the amount. So when you think about it, if you have the radius and you want to go to the diameter, you times 2, because you're multiplying by 2 to get bigger, to the diameter, to go from one half of the circle to both. But then if you're going already from the diameter down to the radius, you cut it in half. Remember, multiplying by 2 and dividing by 2, they're opposite operations. It's the same thing. They're just opposite operations. You have to know which way you're going depending on which way you started. So if you have the radius, you times 2 to get to the diameter. If you have the diameter, you divide by 2 to get to the radius, because you're cutting it down in half. Does that make a little more sense, everybody? We should have had 25 for that one. Again, any teacher can come up here and say, hey, here are the formulas. Have fun. No, this is not how that works. I want to make sure that you understand the reasons why. One more time. Okay, we have 120 radius. 120 is the radius. What's the diameter? Go, 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 go. 120 is the radius. What's the diameter? 120 is the radius. What's the diameter? Yeah, we really have to think about that one more time. Okay, so the answer here should have been 240, because again, the radius is only going halfway. The radius is only going halfway. So in this example, I could have said, hey, the radius is 120. Well, then to get the whole diameter, that would be right over here. And so 120 times 2 is 240. Does that make a little more sense visually for you, my party people? If the radius was 120, that's only halfway. To get to the whole diameter, we multiply by 2. Cool. Sounds good. Sounds good. So with that said, let's go back to the conversation about that really weird thing that we saw with the circumference. Does anybody here remember those two formulas and how they're kind of weird? Like, one of them was circumference equals pi times diameter, and then the other one was circumference equals 2 times pi times radius. Has anybody ever wondered, like, why do you give us two formulas for the same thing, and how am I supposed to know that they're actually the same thing? Has anybody ever wondered that? Like, this is a 30-second conversation. If you understand what we just did with the pop quiz, then you'll understand what this is. So let me go ahead and just change the colors to help you notice. Everyone, is it true, as we've already seen, is it true that the diameter is double, is it true that it's double the radius? Is it true that the diameter is double the radius? Is it true that the diameter is double the radius? And that's where it comes from. The formulas are the same thing. These are the same formulas, because what we're saying is, hey, look, I'm going to tell you that here, this is true. The circumference equals the product, or multiplying, pi times d, pi times diameter. That's going to give it to you. Now, guess what? The diameter is double the radius. What would happen if we replaced d with 2 times radius? This is exactly it. The pi is still there. And instead of putting d, you have 2 times radius. Everybody, does that make sense here? All we did was replace the d with 2 times radius. It's the same exact formula. It's going to be up to you to choose which one you want to use, because guess what? Some problems might tell you the radius and ask you to find circumference. Other problems might give you diameter and have you find the circumference. Knowing both formulas, knowing why it makes sense, makes it faster for you. You have no idea how many people I've coached where before I coached them, they would be going ahead and saying, okay, they gave me the diameter. I'm going to go ahead and cut the diameter in half first, and then I'm going to plug it into the 2 pi r. What? You're taking an extra step for literally no reason. Knowing both formulas is a good thing. Yes or no in the chat box. Do we have that? Knowing both formulas is a good thing. They are literally the same exact formula, just based on if you have the radius or the circumference given to you. Awesome. Awesome. Excellent. All right, so with that, there we go. I'm going to leave this up here one more time for 5 more seconds, because right now what we're going to do, oh, thank you, JB, by the way, for reminding me. Remember that the circumference is the distance around the circle. So let me write this here in blue. Circumference. The circumference is the distance around the circle. Okay? That's the circumference, the distance around the circle, and the area is the space that it covers. So who's ready to start going into some word problems where we're going to be using our knowledge of these definitions to go ahead and start getting things done? All right, perfect. Sounds good. So before we get started, I want to make sure you know this. We may struggle at different points. You might struggle, let's say, setting up the equation, while somebody else might struggle solving the equation. So make sure that we're being patient with each other. Make sure that if you have a question, you ask it. I'm here to answer your questions. I'm here to help you out, but I can't help you if I don't know you need help, or if I'm not explaining something clear enough. Make sure to ask. That's all I ask. So here in this first problem, let's first focus on the setup. Here we go. So before I even begin, for those of you that have been to my classes before, what's the first thing we got to do? That's right. So for those of you who don't know what RTQ means, RTQ means read the question. That's all it means. Step 1 is you're trying to determine what is it that you want. Look at the top left of the screen there. We're asking, what do I want? And that means read the question. So let's go ahead and highlight the question sentence. Always start with the question sentence. What is the distance around the wheel? Okay, everybody. It's not every day that you run into ASVAB practice questions that literally give you the exact idea of what you're doing. But when it comes to geometry, and I've said this all the time, the main advantage you have with geometry word problems is that the question 99% of the time gives you the math. Like, they have to give you enough of a key phrase or keyword to help you understand what's going on. They have to. And when it comes to geometry, most times they make it more obvious than not. Look at the question again. It says, hey, what is the distance around the wheel? Now, let me just go ahead and show this. Before you even talk to me about, oh yeah, this is a circle, let me show you why. Number 1, everybody, first of all, what math idea is related to that phrase? Don't worry about the wheel, just the first part there. What is the distance around the blank? What math idea does that really relate to? Yeah, a lot of us, and you can, if you want to say perimeter, that's correct, because I didn't tell you what shape yet. If you're assuming circumference, actually, you're correct, but it may not be totally representative of confidence in you. If you read any average word problem and you read, what's the distance around the house? What's the distance around the neighborhood block? What's the distance around the rectangle? What's the distance around anything? Most times, a reasonable person who's had reasonable practice would say perimeter before circumference. Is that fair to say, everybody? A reasonable person might think perimeter before circumference if we didn't give the shape. Okay, so let's take a look here. What's the distance around the blank? Now we know that this is talking about circles, but typically you're thinking perimeter, but you have to confirm it with the shape. And when we see a wheel, everybody, reasonably speaking, what's a wheel and what shape? Right. We can reasonably safely assume that we're talking about a circle here. We can reasonably safely assume that because that's what a wheel looks like. So boom, the distance around that tells me perimeter or circumference. And it's because they tell us it's a wheel, that's why we know it's circumference. Does that make sense, everybody? Because they tell us it's a wheel, that's how we know that it's a circle. Good. So step one, what do we want? Well, step one is we want the circumference of a circle. We want the circumference of a circle. So with that said, help me out, everybody. The first thing, once you know what exact math idea, especially when it comes to geometry, if there is a formula associated with it, you have got to be able to regurgitate and throw that formula up at a moment's notice. So could everybody please do me a favor, as quickly as you can, type out the formula into the chat box. And be completely clear, please. Say C or circumference equals, like write it all out. Go ahead. And so JB, again, remember, when you're talking about a circle, the more formal term is circumference, but I will not kill you if you use the word perimeter. Just every now and then it's fine. Just know that you're applying the formula for a circle. Okay, so one thing I see here is that some of us are giving one formula, some of us are giving another. Some of us even tried filling in the numbers already for the problem. Right on. Okay, so my party people, how do we know which one we should use? Like, why did you choose your formula over the other? Because remember, there are two formulas. Why did you use the formula that you used? iPhone, don't worry, I'll talk about the formula right now too. I got you. Lambda, thank you. We're given the diameter. Whitney, it says the diameter, right? Kai, it's already giving diameter. The keyword was diameter. So the thing is, we should know the formulas already. Let me go ahead and let me write these down for you and to remind you. The two formulas for circumference, one of them is circumference equals pi times diameter. And the other one is circumference equals pi times, 2 times pi times the radius. And again, remember, they're the same formula, same exact formula. The diameter is double the radius. So translations of each other, they're the same. But when you look at the information now, once you go from the question, I want the circumference, to what information we have right here, we see that it tells you the diameter of a wheel is 30 inches. So because we're given the diameter, which formula does it make more sense to use? The first one or the second one, everybody? Which formula does it make more sense to use? Because we're given the diameter, we should use, the first one. We should use the first one. But would both of them work? Yes, but the second one works if you have the radius. And you can easily find the radius if you do some quick math, but it's not necessary. Know both formulas. That way, when you're given one or the other, you can do the math quicker. You want to use the first one. We want to use the first one because we're given the diameter, and we'll plug that in, and we're done. Step 3, that's the connection. Circumference equals pi times diameter. Everyone, we know what the diameter is. What should we use for pi? Does it tell you in the problem? What does it say? 3.14. So right here, just pay attention. It says use 3.14 for pi. So that's what we'll do. So I'll go ahead and say circumference equals 3.14 multiplied by the diameter, and that was given to us as 30 inches. And so boom, that's it. Now we're done. All we have to do is figure out what the heck 3.14 times 30 is. And this is where we will take a quick second to just remind ourselves about how multiplying decimals works. So let's go ahead and take it over here, and I'll show you how to do it. 3.14 times 30. So everybody, let's remind ourselves, how do we mess with decimals again? What's step number one? Who remembers from my decimals classes or recording? What's the first step when it comes to multiplying by this? Exactly, Jonathan. Ignore the decimal. Ignore it. Just multiply normally. Multiply like you would with any large numbers. Just do it. Ignore the decimals. So step one right here. Ignore the decimals. And excuse me if you hear my dog snoring. He's literally right there and he's being really loud. But ignore the decimals. And number two, once we multiply, what do? That's right. That's right. We bring them back after. We bring them back after. And here's what I mean by that. Everyone, I'm gonna do this at the end. So step one, just ignore the decimals and multiply like normal. Let's go ahead and go through that right here. So everyone, here we go. 4 times 0, that's going to be 0. 1 times 0, that's going to be 0. 3 times 0, that's going to be 0. Okay, cool. That was actually pretty hard. Now, next up, we'll go ahead and since we're going into the tens place with the 3, we're going to line up the 0 right there. And now we'll multiply again, starting from the beginning. So here again, 4 times 3, that's going to be 12. Then we carry a 1. 1 times 3, that's 3. Carry the 1, that's going to be 4. And then we have 3 times 3, and that's going to be 9. Cool. So we have that going on, and we'll go ahead and add this all up. And that will give us 0, 2, 4, 9. So we've achieved step one. Ignore the decimals, just multiply. Step two, we'll bring it back now. So how many decimals did we have to begin with? I see that on the 3.14, I have 1 decimal place, 2 decimal places. And then on the 30, well, there's the decimal place. It didn't go anywhere. We're good. So we have 2 decimals that we're bringing back, and that's what we'll do. 1, 2, right there. And so, boom, our final answer is going to be the circumference equals 94.20 inches. And that will be our answer. So let me go ahead and just zoom out a little bit and allow you to kind of just soak this in. Because anybody could ask you, hey, go ahead, just copy it down, take your notes. But I really want you to go ahead and just understand what just happened. Oh, for sure, Dominic. Yeah, that definitely works. And that's a more advanced strategy. You know how I teach. That's definitely a more advanced strategy to think about. But I really want to make sure we get the fundamentals down first. So good job pointing that out. It means that you're closer to being at the mastery level than you are at the beginning. It's cool. I like seeing that. Hey, right on, Abimail. So look, again, shout out to Abimail who went ahead and did multiplying decimals in the Math Basics Progress book today. There we go. And it makes it so much easier, right? When you deal with word problems, it's like half the work is done. You just have to get to the calculation. But once you're there, you know you're confident enough to do it. So I love seeing that. So go ahead, on a scale of 1 to 10, how confident are you that you could do a problem like this if I gave it to you again? Okay. So I love that question that I saw. I didn't see the name, but someone just asked, hey, are they always going to be using 3.14 for pi? No. The straight answer to that is no. Sometimes they'll tell you to leave pi as pi, and other times they might make you use 3.14. So you always want to pay attention to the directions of the question to understand whether or not you want to keep it as pi or if you want to change it to 3.14. Always see the directions of the problem. It'll always be listed typically at the end. Exactly. If it's needed, they'll tell you to use the approximation for pi 3.14. Pi is actually like a really, really, really long decimal. So instead of using a long decimal, since we can't use calculators, for the ASVAB, they might just have you do 3.14. Yeah. All right. So let's go ahead. Let me go ahead and just zoom forward here. Let me see if I can find. Cool. I want to give you guys a chance to try this one now. And I'm going to give you 2 minutes to really try this out. So again, pay attention to what the question is asking you to do first, then take a look at the information, and then make a plan. So let me give you 2 minutes here, and I'm going to run the timer right there. Perfect. And then I'll be right back in 2 minutes. Go ahead. Try to set it up. I'm not asking you to get a solution. All I'm asking you to do is see if you can get somewhere further than you could have before. Go. And time. So I am not looking to see if you got an answer. If you did, go ahead and plug it in. But I'm not looking to see if you got an answer. More so, I'm just wondering how you're feeling about this so far. So I asked you after that first question, your ability, if you think that you could do it again, if I presented it to you. I did present it to you. So everybody, my question is this. Did your belief in your ability to do the problem match up to how you feel now? Or are you better or worse than how you felt? Talk to me. Okay, some better, some feeling a little worse, some feeling so and so. Got stuck on how to set it up. I'm so lost, a little better, feeling worse, feeling better. Okay. And remember, it doesn't, it's not going to take just one example and then you're a master at it. You have to learn what's called nuance, the little details that are annoying, but in the grand scheme of things, they mean all the world to it. So let's go ahead and focus on the nuance, on the little details. Everybody, remind me, step one of every word problem, any topic, what's the step? What's the first step? Read the question. Remember, guys, you do not want to read the information first. The information doesn't matter until you know what you're supposed to do with it. So step one, read the question. So right here, what is the distance around the edge of the circular table? So everyone, if you could, in one word, describe what it is that we're looking for, what is it in this question? So Rodney says circumference, Drew says area, Remy says area, diameter, circumference, area. So I'm going to go with Kamani's answer, and that is circumference. And let's really understand why, everybody. Remember, when in doubt, draw it out. Whenever you're in doubt, see if you can imagine what's going on in your head or actually physically draw out on paper what you're talking about. So right over here, it says, what is the distance around? And then it says edge of the circular table. So, like I said earlier, nobody can freehand draw a circle, but okay, just go ahead, try it out, do your best. Unless you're me, because then you can just freehand a circle any day of the week. Yeah, that was me by hand. I didn't use any help. So we're here. Nope, I didn't just edit that. All right, so there we're looking at this, and we have this circle. Let's call it a table. Now, everyone, remind me, what's the distance around again? What's that word again? Right. That's the circumference. Distance around the circle is circumference. Let me write that down for you. The distance around a circle is the circumference. And let me write this down upside here. Circumference. Okay, so you can write that down either way. But again, that says circumference. I know that's a little weird since it's like kind of curved. But yeah, the distance around the circle is circumference. The space inside of it is the area. So again, this is all practice. All we're doing is practicing the terminology. So before I continue, yes or no, does it make sense now that what we're looking for is the circumference of the circle? We're trying to go around it, measure around it. That is circumference. Cool. Because again, remember, we're not going to be perfect on the first try. What we have to do is see what we can understand better. So hopefully that's something that we can pick up. And now what we're going to ask is, okay, since we know we're looking for the circumference of a circle, everyone, what's the next thing that I say to always think of whenever you're given a specific math term that might have I'll give it away if I give the next word out. What's the next thing we might want to do here? Right, we want to think about what we have. But remember, everybody, I always say, or not always say, but I talk about this where if in the question they give you a specific math term, or you can extrapolate it or figure it out or kind of, hint at it, and that term has a formula, everybody, if it has a formula, what's the next thing you instantly want to do in your head or recall? You simply want to be able to state the formula. Okay. You simply want to be able to state the formula and say, hey, we're looking for circumference of a circle. All right. What is that again? We have two actually. There's 2 pi r and then there's pi d. 2 times pi times r or pi d. Everyone, since we have two formulas for this idea here, what do we need to do to know which formula we should use? What's the next thing we should do? Which formula should we use? Right, Landa, Cameron. Yeah, we're given the radius. So we should use the one that includes the radius. So one more time, we'll write this down over here. We have the formula equals pi times the diameter. And then the other one is 2 times pi times the radius. Two times pi times the radius. And so right here, it tells you, hey, that circular table that we're talking about, it has a radius of 3. Again, let's just pay attention right there. Radius says radius. I'm pretty sure it says radius, right? So because it says radius and we're looking for circumference, everyone type out the formula. Fully type it out in the chat box, the formula that we should use here for this problem. Go ahead. That's right. Fully. C equals 2 times pi times r, or circumference equals 2 times pi times radius, whichever way you want to say it. But yeah. Perfect. Good. Sounds good. So again, this is the one that we'll want to use because we're given the radius. So let's type that out here. Circumference equals 2 times pi times r. And then, okay, just fill in the radius. Plug it in. Plug it in. And so we have C, well, that's what we're looking for. 2 times 3.14 times 3 for the radius. Is that looking good to you guys? Did I put that in correctly? No. What you mean? What do you mean no? I didn't set you up for this. What do you mean? Oh, okay. Yeah, I got to use the pi symbol. Let's go ahead and make sure that everybody's on the same page because a lot of people are confused right now. So, everyone, let's make sure that we're making a lot of sense. For the people that said I did this wrong, let's make sure we know what I did wrong. Everyone, I put in the radius incorrectly, right? The radius is 3. I plugged that in correctly, right? Right, I did that correct. What I didn't do correct was exactly what I told you at the end of last problem. Make sure to read the directions to see if you're using pi or if you're actually substituting that approximate value, that 3.14. Just look at the question. Everyone, what does it say on the last line of the question? Right, it says use the exact value. Use the exact value. And I saw someone said that it doesn't even use the decimals. Exactly. The answer choices don't even use the decimals. The answer choices use pi. So that's also another hint that you should be keeping it exactly as pi. So again, different ways you can tell. So with that said, booyah right there. We're going to use the exact value of pi. So I will make sure that this 3.14 right there, that 3.14, I'm going to make sure it stays as pi. So let me make sure you know how to do this math. Let's make sure you know how to do the math. So everyone, just like any variable, a symbol like pi or e, you may learn the natural number and logarithms later. Don't worry about that now. But if you're taking a look at any symbol like pi, well, if you don't have its actual value stated, we'll treat it like a variable. So if you have 2 times pi times 3, you can multiply the 2 and the 3 together. You're fine with that. It's like saying, hey, I have, 4 times x times 5. Well, 4 times x times 5, that's 4 times 5, 20, 20x. That's 20x. Same thing here. 2 times pi times 3. Just take the 2 and the 3, multiply them together, and you'll get 6 pi. And let me explain a little more visually why this is true. So let me just go ahead and underline the 2 and the 3, and that becomes 6. Let me make sure you understand why, everybody. So here, long story short, everyone, do me a favor. Can you calculate for me what 2 times 3 times 4 is? What's 2 times 3 times 4? 24, because 2 times 3 is 6. 6 times 4 is 24. Correct. Sounds great. Let's go ahead and switch the order up. If I switched it to, let's say, 4 times 2 times 3. Can we do that real quick? Is that what's that going to be? 4 times 2, that's 8. 8 times 3, that's 24. Oh, okay. So, quick question, everybody. Can I rearrange the order in which we multiply? Can I do that? Yeah, that's all it is. That's all it is. That's called the commutative property of multiplication. You might have learned that in middle school, high school, depending on what state you live in. But yeah, that's the commutative property of multiplication. Basically saying you can multiply in any order. So the 2 times pi times 3, yes, that is 6 pi. That's your answer. And boom, we are good. 6 pi feet. So confidence level, are we feeling a little more confident that we're understanding what's going on? I'm not asking if you're confident about being able to do this timed under pressure with a recruiter in your face. I'm asking you if you can start talking about this now. Do you feel like you can start talking about this? Like if I told you, like, hey, as a friend, I'm confused. What's the diameter of a circle? I don't know what that is. Could you say, oh yeah, like if you have a circle, if you go all the way across, that's the diameter. The radius is just half of that from the center to the edge, but the diameter goes all the way through. Like if you can start talking about it that way, like boom, that's going to spell success for you down the road for sure. Oh, so how can you remember not to use pi? Again, my response to that is this. Read. I'm not trying to be, what's the word? Patronizing? No, just read. Read the question, read the directions that they'll tell you. it will give it to you. So you're good. They'll make it a lot easier. And the ones that tell you to leave it as pi, I'm telling you, those problems are a lot easier than the ones that have the 3.14. No worries, Landa. Glad to see that. Yeah, Drew, pi is a number, but it's a very, very long number. So we just use a symbol to just talk about it when we're talking about it. But they can tell you to use the approximation. And again, DJ, the way to remember when not to use it or to use it, read the directions that the problem gives you. So with that said, hey, I got you. All this pi talk is making me hungry. Well, pi is actually PI, not PIE. So, I mean, sorry to ruin a good time, but yeah. Plus tomorrow's Taco Tuesday, so save the hunger. But with that, let's go ahead and now look at another question here. I want to look at another question that talks about the same exact idea. Everyone, who remembers this? Fill in the blank. And it's not from today's class. So if you've been to my classes before, you might be able to decipher what I'm saying. Everybody, I might have said this before. Every math idea or math concept has its blank. What should go in that blank? What should go in that blank? Every math concept has its blank. Like, for example, if we're talking about solving equations, its blank would be order of operations. If we're talking about multiplication, its blank is division. If we're talking about addition, its blank is subtraction. If we're talking about squaring something, its blank is taking the square root. Think about it. Addition and subtraction are what? Multiplication and division are what? Opposites. 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 Every idea has its opposite. Every idea has its opposite. Now, what I mean by that in this particular sense is, everyone, did you notice that with these first two examples, all we did was plug the number into the formula, and then we just multiplied and we found the circumference. We were given the radius and we did that. We were given the diameter, and we did that. But notice that in either example, we weren't given the circumference and asked to work backwards. So let me show you an example of a problem that you should be prepared to do, because it's the same idea. It's still circumference, but you need to learn how to work backwards. So let me show you this. The distance around a coin is measured to be 6 pi centimeters. What is the radius of the coin? So let's go ahead and learn how to tackle this. And I'm going to show you why it's actually not that crazy to do. Very, very doable, but I want to give you the confidence that you need. So number one, everybody, just to keep it disciplined, what's the first thing we should always do with word problems again? Yeah, stay disciplined, stay disciplined, stay disciplined. First thing is read the question. What is my goal? What's my objective? Why am I here? Why do I care? Right here it says, hey, what is the radius of the coin? Everybody, if they use the word radius directly, if they say radius, what shape are you guaranteed to be talking about? Right. Guaranteed to be talking about a circle. Unless they specifically mention like a cylinder or something like that, well, then that's a different story, because a cylinder is just the 3D version of a circle in a way. But we don't have to think about that yet, because we will go over that class in a second, or not a second, but in a couple classes. But yeah, so radius of the coin, to keep things simple, when you write down what you want, just say the radius of a circle. They could say coin, they could say circular table, they could say wheel, they could say whatever. The fact of the matter is, you're talking about a circle. Keep it factual. So we want the radius of the circle. Now, just to keep the conversation going here, from that question right there, what is the radius of a circle? Do you automatically know what formula you should use? Yes or no? Based off of just that sentence, only the red, what is the radius of the coin? Only based off of that, can we safely assume the formula we're going to use? Okay, if you're saying yes, then what's the formula? Based only off of the red highlight, what is the radius of the coin? Only based off of that. What's the formula that we're going to use? Tell me. A lot of people said yes. That was a lot of yeses. I see diameter times 2, or diameter divided by 2. I see C equals 2 pi r. I see C equals 2 pi r. I see diameter divided by 2. I see D divided by 2. How do you know? Nowhere in the question sentence, nowhere in there were you told, oh, here's the diameter, or here's the radius, or excuse me, here's the circumference, or here's the area. They didn't say that in that sentence. I'm just trying to show you when you can assume the things you can assume. One of the main questions I get is, Coach, when can I tell that I'm supposed to use this formula? Everybody, have you ever asked that question before? Coach, how can I tell when I'm supposed to be using this formula? Right? You've asked me that a million times. So this is where I really want to be careful about drawing the line. Because yes, we're doing a class in circles. Yes, we're currently talking about circumference. But no, I don't want you to assume that every single problem is circumference of a circle. I want you to learn why it's the circumference of a circle. That way, when you see this mixed in the practice test, you can identify and say, yeah, this is a circumference problem because here they tell you the distance around, here's the radius, so we use this formula. As opposed to memorizing questions and hoping that they'll be on the test. We've all been there. Don't even tell me if you've been there or not, because I know you have. And so what we want to do is understand the reasons why. It's a patient process, but I think you'll appreciate this later on. So what the way that we can tell that we're going to be using the circumference formula is here. The distance around a coin is measured to be 6 pi centimeters. Everybody, if we draw the coin, what is the distance around it again? What's the term for it again? What's the term for the distance around a circle? What's the term? Not the number. I'm not asking for the number that they give you. What's the term? When I say the distance around a rectangle, I want you to say perimeter. When I say the distance around a circle, I want to hear what? Circumference. This is how you know. This is how you know that you're dealing with circumference. You're dealing with the distance around a coin. And since you're looking for the radius and you're given the circumference, the circumference is given to you at 6 pi because you want to find the radius and you're given the circumference. I'm going to use the formula of the circumference of a circle, the radius version of it, to solve my problem. Everybody, does that make sense? That's the connection. You're trying to find the radius and you're given the circumference. The connection is the formula that uses both of those terms. And the formula that uses both of those terms is the circumference equals 2 pi r. And that's how we know that we should be using this. Yes or no? Does that make sense? Right there. I'm just highlighting that for you so you know what the connection is. So that's really what you always want to think about. Like if there is a formula involved, you want to think about, or if you're using formulaic terms, you want to think about like, yo, what's the formula that uses this and this, or everything that you have available to you, or even some of it. But that's how you'll build those connections. C equals 2 pi r. The other formula was C equals pi d. We don't need to use that one. We only want to use this one because it uses what we have. So with that said, everybody, what should I replace the circumference with? Samir, yeah, that's correct. You're pretty ahead. You're good. And Glenda, follow along here. So Glenda, the one thing that we want to understand first is that they gave you the circumference as 6 pi. So if we're going to be filling in the information from the formula, this is C right there. So I'm going to fill that in with 6 pi. Exactly what it was. That was a little too squiggly there. But there's 6 pi. Then I'll go ahead and write the 2 times the pi. Everybody, what should I fill in for radius? Well, nothing, because that's what I'm looking for. That's it. But here's the problem, everybody. This isn't like the other problem where you just plug in the radius and you do it, or plug in the diameter and you do it. We have the circumference, and now we're trying to find the radius. So let's check this out, everybody. First off, let's just worry about the regular numbers first, the 2. Let's get rid of that 2. Everyone, what's the opposite of multiplying by 2? How do we get rid of that 2 again? If we're solving equations, we're working backwards, and we're doing the same thing to both sides. Again, we're working backwards, and we're doing the same thing to both sides. So what I'll do is I'm going to try to get rid of that 2 by dividing both sides by 2. Once I do that, the 2's cancel out, and 6 divided by 2 becomes 3. The pi is still there, and we still have the pi times r over here. But here's the thing, everybody, remember, is it true that pi is just a number? We just use a symbol to represent it, but pi is just a number. It is. So everybody, remind me again. What's 2 divided by 2? 1. Okay, great. What's 5 divided by 5? Oh, 1. Okay. What's x divided by x? No, x divided by x is just 1. Anything divided by itself is 1, right? So with that said, what's pi divided by pi? 1. Anything divided by itself is 1. Remember, division is just saying how many groups can you make out of this? You can only make one group of yourself. So with that, we can divide. You see it. This is multiplication here. We can divide both sides by pi to get rid of it. Because again, remember, the goal is to get the radius by itself. That's the goal. Trying to get the little radius by itself. And what happens here? Pi divided by pi cancels out. Oh, and guess what? Pi divided by pi also cancels out. Nice. And that gives you the answer. Equals 3. And there you are. There's your answer. Let me zoom on out just a little bit. But there's your answer. It'll be C. 3 centimeters. And there you go. And the thing is, Drew, with practice, look, think about it like this. Drew, I don't have these formulas written in front of me. You asked me about radius, that's half the diameter. Diameter is double the radius. Area of a circle is pi r squared. The circumference of a circle is 2 pi r or pi d. I mean, with practice, this will become knowledge and nature to you. Just like a phone number. Like if you get someone's phone number, obviously in today's day and age, you don't need to remember anybody's phone number. But if I gave you a phone number and I said, hey, you're going to call this phone number from this piece of paper 100 times, after the third, fourth time, you'll probably know the number. So, and like true or false, is that true for some of y'all or most of y'all? Like if I gave you a phone number on a piece of paper and made you dial it 100 times, by the third or fourth time, you'll be good. You would have remembered. Yeah, so that's the idea. Guys, that's the idea. Use it to remember. If you want to remember it, use it. So here's the problem again, so you can screenshot it before we move over into the next one. Someone said smile in the chat box, by the way. Got to do it. Got to do it. All right, so with that, hopefully that makes a little more sense, my party people. Now, what we're going to do now is I want to go ahead and move forward into area, okay? I want to move forward into area. Farmers only profile picture, that is correct. So with that, let's take a look forward into area. So if you've been to one of my geometry, particularly the area classes before, I want to talk briefly about how we know, just like we've talked about at the beginning of the class, how do we know that we're talking about area in a word problem? Like we talked about circumference. Circumference is when you're talking about the distance around something that's circular, right? That's circumference. Circumference is talking about the distance around something circular. But what's a big hint or hints that we can receive or use when we're supposed to talk about area? So for you, my party people, what are some keywords or phrases that you've noticed tell you that you're dealing with area? And if you don't have any, no worries. Go ahead and just view the chat box. See what some people are saying. And the ones that I'm going to go ahead and shout out that I would, that I think are close enough are the space inside of an object. Absolutely. The inside, the space inside, what the surface covers. Yeah. And Kamani says something pretty interesting. Kamani, I appreciate this more than you know. Kamani simply said the word square. Now, Kamani, is it true that what you mean is square units? Is that closer to what you meant? Kamani, let me know if that's what you meant, square units. Yep, because that's what gives it away as well. So 2 big hints for area. Let me go ahead and write this down for you here, my party people. So 2 big hints for area. So 2 big hints for area. Number 1, space inside. The space inside of a shape. And now number 2 is, this is a more resourceful one. This is one that will always appear. It will always, always, always appear. Sometimes they won't tell you that, oh, the space inside of this object is. They may not always say that. What they will always say is, hey, this circular object covers 60 square meters. So whenever you see a number given with square units, that is area. Remember that regular distance is perimeter, square units is area, cubic units is volume. Square units is area. Square units. That is a big, big hint for you. And this is how you're going to spot this here. So first, we're going to read the question. The question says, how many square meters does the surface of the circular swimming pool cover? Everyone, let's break this down. This is almost like it's magic once you know exactly what you're looking for. Watch this. Number 1, how many square meters? Now, I don't know what shape we're dealing with yet. But everybody, just to make sure we're conditioned to this, the moment that we see square units, so square meters, what math idea do we want to immediately think of? What math idea do we want to immediately think of when we see square units? Area. Yes. Immediately, square meters, that is area. And then it says, how many square meters does the surface of the circular swimming pool cover? Now, why is it important, everybody? Well, think about it like this. If you knew you had to find the area, my next question is, what's the shape? Is it side times side? Is it length times width? Is it 1/2 base times height? Is it pi r squared? Which one? And to answer that, we need to know the shape. Everybody, is that making sense? Like the process I'm going through? Now that we know that we're looking for how many square meters, so what's the area, we now need to point out what the shape is, because it dictates what formula we're going to pick out. So boom, right there, it says circular swimming pool. So area of a circle. That's how we brought it together there. That's how we brought it together. Can anybody remind me what the area of a circle is? Full statements only, please. Give me area equals blah, blah, blah. Zoom users appreciate that. Anybody else? Is that the only person that knows the area of a circle? Wow. There we go. A little more lively now. Good. Yep. Area equals pi times radius squared. Perfect. So that's what you want to do. Immediately, now that you know the area, now that you know what shape, boom, what's the formula? Area equals pi times the radius squared. You can say it like that, or you can say it like this. Pi times r squared. You might also see it as pi r squared. They all mean the same thing, guys. These are all the same thing. All of these are the same thing. So everybody, just take a look here. We're looking for the area. Now, based on the formula, you got to be very careful here. Based on the formula, what do we need to plug in to find the area? No, but what term? Not number. Yeah, we need to plug in the radius. And okay, so now the obvious question is, what's the radius? Everybody, give me the radius. What's the radius of the circle that we're dealing with again? Give it to me there. Okay, cool. So let's go ahead and write that down. And let me go ahead and show you what it's like when a student rushes and may not particularly notice some of the content that they're looking at. So, okay, we need the radius. Okay, sounds great. And I'm going to say that the radius, okay, it equals 20. Okay, sounds great. Perfect. Okay, cool. So you guys saw 20 meters. Congratulations. You can go ahead and pull information from a problem. Sounds great. Right? Yeah. I'm glad you guys are seeing in the chat box there, right? So for those of you that haven't caught on yet, no worries. This was just a quick little exercise in, can you spot my mistake? Can you make mistakes when you rush? The answer is always yes. You can always make mistakes, even when you don't rush. But when you do rush, you do leave yourself open to making more mistakes. When you practice, it's important to always justify why before moving forward when you practice. Here's why 20 meters is not the radius. It says the distance across the circular swimming pool is 20 meters. Let's go ahead. Let's take it back over here. Again, my perfect circular drawing skills. Boom. There's my circle. And then it says the distance across is 20 meters. Okay. Everyone, quick question. Without any context, that 20 meters, what is that describing of that circle? Can you give me a formal term, a formal math term? What of the circle are we describing with the 20 diameter? Yeah, that's the diameter. This is the diameter. Remember, everybody, the problem, the formula, we need the radius. Oh, actually, that would have been wrong then, because the diameter was 20, not the radius. But that's not the end of the world. This is actually a pretty quick fix, right? Because didn't we say and have a little fun earlier when it came to, hey, if we know the diameter, can we find the radius? The diameter is the bigger one. The radius is the smaller one, right? So what's the radius going to be then, everybody? What's the radius going to be? Yeah, it's 10. So remember the idea earlier was that, well, you cut the diameter in half to get the radius. So 20 divided by 2 equals 10. The radius is 10. And so I can illustrate this for you right here. And that's going to be the radius. And that's what we should use and not the 20. And if you might have noticed that one of the answer choices, I believe, might be based off of that. Oh, no, not this one particularly. Yeah, not this one particularly. But some answer choices, they will be based off of common mistakes. I've programmed that into my problems that I've created. Not this one particularly because it's randomized, but in some problems, you will definitely see that. And so here, the radius that we're using is going to be what again? Who remembers? Radius is going to be what? 10. And so we'll plug that in. Area equals pi times 10 squared. And so the next question really quick is this. Do I need to use 3.14 or keep pi as pi, everybody? Do we use 3.14 or do we keep pi as pi? Right, keep pi as pi. Just keep it as pi because you see right here. Use the exact value of pi, which is just the symbol. Exact value means just use the symbol. And you can tell in the answer choices that we're still just using the symbol. So hopefully that's not confusing. But now that we're here, it looks like all we have to do is figure out what 10 squared is. Everyone remember, squared just means multiply that number by itself 2 times. 10 times 10. 10 times 10 is what? 10 times 10 is what? 100. And so the answer, the area, is 100 pi square meters. And there's our answer. Boom. And there is our answer, 100 pi square meters. How are we feeling, everybody? Are we starting to slowly see that, again, no matter how much apprehension we might have toward these difficult seeming concepts, it's still possible. Are we starting to see that, guys? Like, as slow as it might be, because circles isn't the easiest topic. I'll tell you that right now. There's so much that you have to wrap your head around, like the terminology, the keywords and phrases, the formulas, the calculations. There's so much that you have to wrap your head around. But I just want you to see that it's possible. It's possible, because before you start believing that something isn't impossible, you have to make sure that you can at least see yourself walking those steps, walking that line. And we've done that multiple times here. So with that said, nice. Great. And so with that said, we're going to get into another problem, but right after I answer these 2 questions. So the first question was, hey, coach, why did we break down the 20 into 10? Just to remind you, or as a recap, the formula here says that we need r, the radius. Let me highlight that for you right there. So we need that radius. The problem described the distance across the circle. That's diameter, not radius. So we just needed to do a quick little translation. We were given 20. That's the diameter. We wanted the radius, so we cut it in half. That's how we got the 10. And the reason, Xavier, why we did the 10 times 10, after which, when we plugged everything in, is because the square here, so if I do 10 squared, this means 10 times 10. If we were asked to do 10 cubed, well, that would mean 10 times 10 times 10. Again, the exponent just means how many times you're multiplying that number by itself. That's all it means. So Xavier, let me know if that makes sense. Let me see the name on the other person. Samsung, yeah, that's why I didn't remember. Samsung, let me know if that makes sense too. And then we'll move on to the next one. Oh, and by the way, everybody, so it's about 20 minutes till class ends. So in tomorrow's class, we're doing a follow-up on this. We're doing part 2 tomorrow. So today, you see how we're going nice and slow, understanding every single problem. Tomorrow, we're doing drill sets for an hour and a half. So it's going to be problem after problem after problem. We just have to make sure we cover the rest of the notes. And boom, it's going to be all practice tomorrow. Got you, Xavier. No problem. So with that said, my party people, let's go ahead and go into this next one here. Not that one. Let's do this one here. So go ahead, my party people, give this one a shot. I don't expect you to do all the calculation. I just want to see if you can set this up. So go ahead, take a quick 2 minutes on this one and try it out. And so the timer is coming up right here. Booyah. So go ahead and give it a shot. I don't expect you to get all the calculations in, but if you have enough time, again, test your skills out, try it out, but try this one out here. And for the person who's asking in the chat box, how will this help you for the PICAT? This is one of the concepts that you'll be dealing with. Circles, you can do circumference, area, radius to diameter, diameter, radius. You just have to know all those things because you'll probably have around 1, maybe 3, but you're likely to see at least 1 of these on the test. Cool. So we have 1:15 left. Give it a shot, and I'll be back. Oh, and by the way, for those of you that, again, were interested in the free trial for the program, again, 7 days, no credit card required, you can go ahead and request your trial here with this link. All you have to do is follow the directions on that video, but I do want you to wait until after class. I'm just posting this for the people who need to leave early. Again, there's a link for the trial. Boom. So if you're on YouTube, I just posted that in the comment section as well for you, okay? But again, wait till after class. We have 30 seconds left here. Cool. And time is up. So again, the point here is not to ask you, hey, did you get a final answer? No, not the point. My question is, were you able to get a setup in? Were you able to set this question up? Were you able to set this up? Right on. So let's go ahead and let's try this out here. First things first, we'll start by reading the question. The question says, what is the area of the circular driveway? Wow, that's pretty blatant there. And that's the thing about circles, everybody. When you're talking about circles, like besides saying distance around it, they're probably going to give you the direct math terms. So here, area of a circular driveway. Okay, area of a circle. Everybody, state it in the chat box. What's the area of a circle? From memory, try to do it from memory. What's the area of a circle? Dominic, only give me one there. What's the formula for the area of a circle? The formula for the area of a circle. Yeah, in general, yep, pi r squared. Pi r squared. So here, area, circular driveway. We're looking for the area of a circle. It's going to be pi times the radius squared. And again, the shorter way is pi r squared. Same stuff, but what you're going to do is you're going to take the number for the radius, square it, and then multiply it by 3.14. So with that said, let's look to the information. Are we given the radius? Let's see. Are we given the radius? So it says that you find that the radius of a circular driveway is 24 feet. Okay, everybody, so let's go and remind ourselves, and let's try to make sure we don't make the same mistake again. In the previous problem, we had to divide the number that they gave us by 2. Do we have to do that here before plugging it in? Do we have to do the same thing here? Answer is no. And I think a lot of people, okay, cool. The consensus is no. Everybody's saying no here. Now, why is it that we don't have to do anything to that 24 that they give us? Why is it that we don't have to do it? Hey, no worries, JB. Exactly, everybody. It's the radius. We need to plug in the radius to the formula. We're given the radius in the problem. No problem there. No big deal. We got it. Boom. Radius is 24. Okay. That's that right there. So yes or no, before I continue, do you see why we don't have to do anything to that 24? It is the radius, so we can plug it in for the radius. Do we see that? Good. Cool. I'm glad. Again, like I'm taking these pauses because these are the points where, through my experience as a teacher, I've seen some of these common mistakes develop. So even if you're good on this part, trust me, there's at least 15% that do need that reinforcement there. So I do appreciate you guys being patient and really acting like a team here in a class. I loved it. So with that, boom, we'll plug in R for the radius. And what's one more detail that we have to take into account? What's one more detail that we need to take into account? Right. In this problem, we're using 3.14 for pi. So with that said, it's going to be area equals 3.14 for pi. 3.14 for pi. The radius will plug in 24. That's 24. Let me just use blue for that, actually, just to make it a little better on the eyes. 24 squared. So PEMDAS, order of operations, we're multiplying and we have an exponent. Everyone, which one happens first? Order of operations. Correct. Exponent first. So we'll do 24 squared. And remember, 24 squared, anything squared, is just that number multiplied by itself. And so here we'll do 24 times 24 on the side, and we'll figure out what that is. 4 times 4, that's going to be 16. Then 2 times 4, that'll be 8. Carry the 1 is 9. Next line, we'll plug in that 0, and we'll do the same thing again. 4 times 2 is 8. And then we have 2 times 2 is 4. Boom. 6, 0, 6. 9 plus 8 is 17. Carry the 1 is 5. So that looks ugly, I know, but that's 576. It's lazy writing on my part. Sorry about that. But now we can say area equals 3.14 multiplied by the 576. And so this is the part of the problem-solving process that if you have gone through the math basics and you've gone through all of your fundamental practice, this should not stop you from believing that you can get this problem right. If you're looking at this step and you're saying, oh, hell no, or anything like that, well, that probably tells me that you have not practiced enough or actually mastered this concept of dealing with decimals. So if you put in the time and you put in the effort and the consistency, this doesn't stop you. Getting to this point, you're happy because you know that you're good. So here we go. So with that, we have 576 times 3.14. And here we go. We'll work on this. So here's 6 times 4, 24. 7 times 4, 28. Carry the 2, 30. 5 times 4 is 20. Carry the 3 is 23. Cool. Then up next, I'll use green for the next one for 1. We'll go and put the 0 down. 6 times 1 is 6. 7 times 1 is 7. 5 times 1 is 5. Sweet. Then lastly, I'll use blue for the 3 for the last digit. So 0, 0. And then from there, 6 times 3 is 18. Excuse me there. Right there. 7 times 3 is 21. Carry the 1 is 22. 5 times 3 is 15. Carry the 2 is 17. And you just keep calm, cool, and collected, knowing that with your practice, you can spot mistakes while you make them if you do make them, and you can finish the problem off the right way. And there we go. And so then lastly, the last step that we have to do is just go ahead and bring back all of these decimal places. So we see that we have none at the top. Let me use red here. We have none at the top, and then we have 1, 2 right there, and boom. 1, 2. So our final answer would be 1808.64. And since this is area, that would be square feet in that case. And so with that confidence, boom, there it is. And we're feeling pretty good. And we're feeling pretty good that we can get a problem right. But notice how there's so many different things that come together. Not just our ability to, hey, what does that word mean? What does that key phrase mean? But on top of that, knowing every formula that we could possibly need to use, but that comes with practice. Then actually completing the formula or solving for any piece of the formula. Here, we're still going forward by plugging in radius and finding area. But can you do a problem where we have the area and we got to find the radius or the diameter? We need to be able to do those problems. And so we'll do that as the last problem of the day. Let me go ahead and get my face out of the way here so you can take a picture of this problem if you'd like to. 5, 4, 3, 2, and 1. So before I proceed, before I move over into the next one, I want to know from you, did you already have this down, this specific problem? Did you make a mistake and then catch it? or are you still confused? So again, were you good all the way? Did you learn something from this problem? Or are you still just as confused as when you started? Nice. And again, be honest. Yeah, because I want to know who's struggling. I want to know who's having a good time or who's advancing forward. Because once I know that, then I can adjust my teaching. So with that said, my party people, hey, no worries. No worries at all. So for this last one, what I'm going to do, because it is 7:52, and tomorrow we are following up on this, and everybody here can join because everybody here can get the trial for the program. I'm going to go ahead and I'm going to show you the previous question here. I'm going to give you the answer, and I want you to try it out yourself, because with the remaining time of the class, I want to set you up for success and tell you all of the things that you need to be ready to handle before you can truly say that you can master this. So the answer to this question is going to be B8. And so let me go ahead and show you again. I'm going to list it out for you, the things that you're going to need to know to be successful when it comes to circles word problems. So need to know. And here's what I invite you to do with this question here. If you want to show me how you got it right, how you got B, because again, I can give you the answer all day, doesn't matter, but can you show me that you know how to get to the answer? So if you want to take a picture of the question and then shoot me a text with it, go ahead, feel free. I'll tell you if you got it right or wrong. My number is 567 698 8867. Feel free to text that to me. I'll go ahead and I'll be on first thing in the morning because I am hopping off at 8, but I will be back first thing in the morning. I can go ahead and check that for you. I got you. But here's what you need to know to be successful with circles. What you need to know is, again, your formulas. So that's going to be, or your definitions and formulas. Radius, diameter, circumference, both formulas. Both formulas. You need to know area. You need to know how to handle decimals or pi, definition of pi versus 3.14. So when to use it. And again, that just depends on the question. Then on top of that, you want to know how to deal with decimals. So how to multiply and divide with decimals. Let me just write this here. All right, so these are the things that you need to know to be successful in circle word problems. And so my party people, the class tomorrow is at the same time, but you're going to see that when we get into these advanced problems, like think about it. Think about what we just did today, and I'm going to hint at what we're going to be doing tomorrow. Today, here's all we got through. We were able to get through, hey, let's define radius, diameter, and if we have radius or diameter, can we get the circumference? If we have the circumference, can we get back to radius or diameter? We worked on that today. That's awesome. Then we talked about if we have the radius or diameter, can we do the area? If we have the area, what we were about to get to, this problem, can we get back to the radius or diameter? Now, here's what we're going to do tomorrow. Tomorrow, we're going to refresh and review this, but we're also going to learn, let me zoom out for you, gotcha. We're also going to learn, hey, if we have the circumference, can we get to the area? If we have the area, can we get to the circumference? Also, what are some other problems? Like, how far will a wheel go that has a radius of 3 centimeters? How far will it go if it turns 100 times? If it turns 80 times? 75 times? How far will it go after a certain number of spins? That's what we're going to work on tomorrow. But we have to have these down here to be able to have that conversation. Yes or no, everybody? Does that make sense? Perfect. And so I really do hope you guys can make it to tomorrow's class. Here's the last screenshot here, so you can take it if you want to. I'm going to go ahead again. If you're here for the first time and you want to join the program, again, it's free. No credit card required for 7 days. So I'm going to go ahead and cap off the class right here. So give me a moment. I'm going to give you the links again to go ahead and register for it. So right over here. So remember, this was Unit 10 in the Arithmetic Reasoning. Please, if you're feeling like you're struggling on this and you haven't finished the math basics first, finish the math basics. That's the first thing I tell you to do when you join the program. It's in the welcome email. It's in the welcome text. It's in the text messages and emails that I send you in the first 7 days of being in the program. I blast you when it comes to finishing the math basics first. It's going to guarantee that you're ready for this when it comes to dealing with those big decimals and big numbers. So I want to make sure you're ready for it. Go with the math basics first. Please, please, please. Now, with that said, yeah, you guys are absolutely welcome, man. You're absolutely welcome. If for those of you that are in the program, if you want to go ahead and just say one comment about the program, could be good, could be bad, just make it honest. For those of you that are wondering about what the program is, I really want to show you the effect it's had on my current students. So go ahead. If you're currently in the program and want to say something honest about it, please do so in the chat box. I'll give it a few moments. Yeah, Dylan, I got you. Here's the link to the math basics. I got you. I'll let everybody go ahead and do that. Yeah, here's your link to your math basics dashboard right here. Damien, I won't let you said it's a waste of your time. It's not a waste of your time. I was like, what? Perfect. So with that said, like, just take a look at those honest comments, guys. So it's free to try, no credit card required for 7 days. Let me just explain what this helps you solve, and I'll give you the link to go ahead and start the trial if you haven't seen it already. So for those of you that are in the program, thank you guys for joining. I'll see you tomorrow at 6 p.m. For those of you that aren't, let's get you signed up for free. So basically, look, if you're the type of person that you think you're smart, but when it comes to performing under pressure, it's like the things that you can do, it's like your ability gets cut in half when you're under pressure and you're being timed. If you feel that way about the ASVAB, then this is going to help you out a lot. If you have trouble with word problems, deciphering the information, translating English into math, putting it all together, and you blank out sometimes, well, this will help you out. Number 3, if you hate guessing and hoping for the best, if you run out of time frequently, if you have to guess in Christmas tree because you can't do 10 questions in the last minute, again, we can help you manage your time and solve that problem. And lastly, if you feel like you're studying alone and you don't really particularly know how to tell when you're ready, again, that's what the program helps you solve. Like, this is 4 years in the making. We've been working on this for a while, and we keep getting better thanks to you guys. So if you feel like this session improved your chances of passing, if you feel like more of this could work for you and access to more materials, then boy, do I have materials for you. And just like you saw in the chat box, plenty of students that have used this program, over 1,000 have raised their scores with me. And I want to make sure that you're there too. So the things that you're going to get, and pay attention, you're going to get access to all of my live classes and all of my recordings. That's over 400 classes that you can watch tonight if you had the brain power. That's a lot of classes. But yeah, there's no way you can watch that in one night. Now, number 2, you're going to get access to over 15,000 practice questions across all of my courses for the AR, MK, WK, PC, and GS. That's great if you want to study on your own schedule. You get video solutions, guided practice, worksheets, flashcards, everything you need, and it's actually all lined up for you with your progress books. So for the math basics, that's lined up. Arithmetic reasoning, lined up. For math knowledge, lined up. Word knowledge and paragraph comprehension, you have your study guides and your practice courses lined up. Everything is there for you from start to finish. All you have to do is sit down and get to work. And if at any point you need help or have questions, you have access to me, my personal number. You can text me whenever you need help. I respond Monday through Friday, typically late morning to 5 p.m. because I am meeting with my team typically every day. But when I'm free, hey, I answer at the very least once a day. So whenever you have any questions, reach out to me. If I'm in office and chilling, hey, I'm going to respond to you really, really quick. That's most cases. So long story short, everybody, there's no reason why you shouldn't try the program because it's free to try for 7 days. So help me, or not help me, help yourself. I want to show you that raising your score is possible. So just go ahead. Let's sign up now. Let's get you going. These are the prices after the fact. And if you go through the trial completely and finish it, you'll actually get a different discount code. And it could be better than this. So with that, go ahead, try the trial out. Here's the link, program trial. I think it's a super simple survey that you're going to fill out. And then I I take you through a confirmation step, and that's it. So there is the program trial link for you in the chat box in Zoom. And here's the link on YouTube. Boom. So with that said, my party people, again, what this helps you out with is everything that is a test taker's nightmare. Not knowing what to study, being able to handle difficult problems, new questions, and knowing that when you take a practice test, what to do with it and how to learn from it every single time. So there it is, my party people. If you have any questions at all for that, feel free to shoot me a text. My phone number right there is 567-698-8867. The next class that we have is tomorrow for circle word problems, and then we'll be continuing next week after that. So we have part 2 tomorrow where we're going to cap everything off. I'm going to make sure you're a master at this before you continue. So if you have any questions at all about how this works, I can go ahead and stay put for the next 4 or 5 minutes, and I'll answer any questions that you have or await the steps for you to confirm. That way, if you have any questions, you're good. I see that you guys have taken good advantage of this already. So I see that we have 1, 2, 3, 4, 5, 6, 7 people that have already started. Oh, that's fast. That is fast. Booyah. And remember, once you sign up, make sure you start with the math basics. Okay? Make sure you start with the math basics. So here's the link one more time. I want to put it in the chat box again. Booyah. And there we have it. So my party people, you guys have been absolutely awesome. If you have any questions at all, guys, please let me know. I'm more than happy to help you out. So reach out to me. Here's my phone number one more time. And I hope to see you in tomorrow's class. It's at 6 p.m. Everybody's invited if you're in the trial at the very least. Booyah. And so I got you, man. Let me know. Go ahead and get into it. Let's have some fun. And again, class tomorrow, 6 p.m. And if you have any questions, text me. If anything's going wrong or not working the proper way, just wait till tomorrow morning. I'll be back in office first thing to help you out. And then on top of that, start with the math basics when you sign up. All right. So with that said, again, everybody, hope you guys have a great evening. My name is Coach Anderson. That's Ace The ASVAB. Long story short. I'll see you guys tomorrow. Thanks for coming. Appreciate y'all.